I'll say that again. All Tesla cars being produced right now have everything necessary for full self-driving.
Welcome to Data Science 360. Let's look at how Tesla's system is so seamless and reliable. Tesla was not the first company to design a driverless car, but they were the first to focus on using big data to their advantage. What does a Tesla vehicle do? The main function of any self-driving vehicle, including the ones at Tesla, is to stay in the correct lane, then to change lanes to follow the right trajectory. Tasks like obstacle detection are a big part of the stack. And other features such as Smart Summon allow the car to find the driver in a parking lot. Tesla is using 8 cameras to function. By doing so, they can cover all areas surrounding the vehicle so that there's no blind spot. How Tesla uses machine learning. Deep neural networks are one of the main components of the self-driving technology stack. Tesla is using 8 cameras to function. The 8 cameras are fused together with additional radars so they can effectively locate obstacles and identify them. Neural networks analyze live camera feeds to identify roads, signs, cars, obstacles, and people. Deep learning is a subset of machine learning. Before we look at what deep learning and neural networks are, let's look at how humans are able to classify different images and patterns. The visual cortex is the primary cortical region of the brain that receives, integrates, and processes visual information coming from the retina. It consists of many neurons that are linked together, which help in identifying patterns and images. Similarly, an artificial neural network is a series of algorithms that endeavors to recognize underlying relationships in a set of data. Through a process that mimics the way the human brain operates, it will have an input layer, processing layer, that can be many neuron layers depending on use case, and an output layer. How do we train this network? We will provide set of images that is labeled correctly. For example, we will group different images of cat or a dog. And the model is trained on this data. When we send a new image that model has not seen before, it will be able to identify correctly. For this to be accurate, we require huge number of training data and high computation power. Tesla used millions of annotated data to train its model. Images are annotated such that model is able to identify vehicles, people, different lanes, traffic signs, and much more. When Tesla's neural network model come across an image that it is not able to identify correctly, this data is collected and sent back to the training set, and the model is trained on this data again. This happens multiple times, so that the model is well trained and make them very accurate. How Tesla manages to process high volumes of data.
Tesla, who has never designed a chip before, would design the best chip in the world.
The Tesla system consists of 2 AI chips in order to support it for better road performance. Each of the AI chips makes a separate assessment of the traffic situation for guiding the car accordingly. The assessment of both chips is then matched by the system and followed. If the input from both is the same, these AI chips have been optimized to run at 2 GHz and perform 36 trillion operations per second. Initially, Tesla had collaborated with NVIDIA to optimize its AI integrated chips. Later, dropping NVIDIA, the company vowed to create its own chips. How Tesla collected data. Tesla effectively crowdsources its data from all of its vehicles as well as their drivers, with internal as well as external sensors which can pick up information about a driver's hand placement on the instruments and how they are operating them. This data is used to generate highly data-dense maps, showing everything from the average increase in traffic speed over a stretch of road, to the location of hazards which cause drivers to take action. Tesla claims they have gathered data from over 100 million miles with the autopilot software. Now, Tesla gathers so much data that it logs more miles in a single day than all the miles Google logged with its driverless car program. Since it began in 2009, all this data has been compiled in the cloud to generate road maps for driverless cars that are 100 times more accurate than standard navigation systems. Thank you for watching. You are amazing. If you liked the video, please do like, share and subscribe to Data Science 360. Be on lookout for more amazing content.